Hello, it's Professor Asma Parveen from Department of Psychology, Aligarh Muslim University. Today I'll be talking about testing of hypothesis and its types. This figure shows the steps involved in testing of a hypothesis, that is, formulating a hypothesis, determining confidence and significance levels, selecting a statistical test, applying the statistical test, and then analyzing the outputs. These are the specific steps in testing a hypothesis that I will explain in detail. Hypothesis testing is a crucial aspect of scientific research as it allows all the researchers to determine the validity of their ideas through evidence based analysis. This process involves several steps that guide researchers toward reaching conclusive results. The first step in hypothesis testing is setting up hypothesis, the null hypothesis, and the alternative hypothesis. The null hypothesis assumes that there is no difference or relationship between the variables being studied, while the alternative hypothesis suggests the presence of a difference or relationship. These initial hypotheses serve as the foundation for further investigation and analysis. Next step is selecting a significance level. When scientists conduct research, they must choose a significance level denoted by the Greek letter alpha. This level determines when they can reject the null hypothesis. The two most commonly used significance levels are zero point zero 0.05 and zero point zero 0.01, which correspond to a 5% and 1% chance, respectively, of mistakenly rejecting the null hypothesis. Next step is collecting data. Once the hypotheses are established, scientists collect data to test them. This data can be gathered through various methods such as experiments, surveys, or observations. It is important to ensure that the data collected is reliable and representative of the population being studied. The accuracy and quality of data play a significant role in drawing valid conclusions from the hypothesis testing process. Next step is choosing a statistical test. And it is a very crucial step in hypothesis testing because researchers have a variety of options including t-test, ANOVA, chi-square test, correlation analysis, and regression analysis. Each test serves a specific purpose based on the type of data and research question at hand. Once a statistical test is selected, researchers proceed to calculate a test statistics using the collected data. This test static quantifies the strength of evidence against the null hypothesis. In addition, researchers compute a p value which indicates the probability of obtaining the observed data or more extreme results if the null hypothesis were true. A smaller p value signifies stronger evidence against the null hypothesis. Next step is making a decision. When conducting a scientific study, researchers use hypothesis testing to draw conclusions based on evidence. This process involves making a decision about the null hypothesis by calculating a test statistic and p value. If the p value is equal to or less than the chosen significance level, the null hypothesis is rejected and the alternative hypothesis is accepted. On the other hand, if the p value is greater than the significance level, the null hypothesis is not rejected and no conclusion is made. After making a decision, researchers interpret the results of the hypothesis testing in relation to the research question and findings of the study. They consider the practical importance of the observed effect or relationship, the reliability of the data, and the implications for theory and practice. The significance of hypothesis testing extends beyond individual studies because it contributes to the overall body of knowledge in a particular field. So, by systematically evaluating hypotheses and testing their predictions, researchers build upon existing theories and expand our understanding of the world. This process of scientific inquiry helps address important questions and challenges in both science and society. There are certain errors in hypothesis testing because when conducting experiments to test a hypothesis, it is important to acknowledge these mistakes and errors that can occur. A hypothesis is, as we all know, is an idea that may be proven right or wrong, and there are various factors that can lead to draw incorrect conclusions. Firstly, the way we design our study could be flawed. This means that the structure and methodology of our experiment may not accurately address the hypothesis at hand. Secondly, the selection process for participant in our study might also be flawed. If we choose individuals who do not represent the target population, our findings may not be applicable to the broader group. Furthermore, inaccuracies in data collection can contribute to erroneous conclusions. It is essential to ensure that the methods used to gather information are reliable and precise. Additionally, errors can arise during the analysis of the collected data. If we misinterpret or miscalculate the results, our conclusions will be compromised. Moreover, the statistical methods employed in our study may not be appropriate. Despite hypotheses require different statistical techniques and using an incorrect method can lead to misleading outcomes. Lastly, the conclusions we draw from the data must be scrutinized. It is possible to misinterpret or overgeneralize the findings, leading to inaccurate assertions. When conducting a hypothesis testing, there are two types of common errors that occur. The first type is known as type 1 error, which happens when the null hypothesis is mistakenly rejected. For example, let's consider a study on the relationship between teacher training and student performance. The null hypothesis in this case would state that there is no connection between teacher training and student performance. If the study results show that teacher training does not actually have an impact on student performance, it would be incorrect to reject the null hypothesis. However, if we still choose to reject it, that would be a type 1 error. The second type of error is called a type 2 error, which occurs when the null hypothesis is not rejected even though it has been proven to be false. Using the same teacher training example, let's say the study results demonstrate that increased teacher training does indeed lead to improved student performance. This means that we should reject the null hypothesis and accept the alternative hypothesis, which states that increased training does have an effect on student performance. However, if we fail to reject the null hypothesis and instead claim that it is still valid, that would be a type 2 error. In hypothesis testing, it is crucial to understand these errors and their implications. Making a type 1 error means falsely rejecting the null hypothesis, potentially leading to incorrect conclusions. On the other hand, making a type 2 error means failing to reject the null hypothesis when it is actually false, which can result in overlooking important relationships or effects. Both types of errors can have significant consequences, especially in scientific research and decision making processes. To minimize the likelihood of these type 1 and type 2 errors, researchers must carefully design their studies, collect accurate data, and use appropriate statistical methods. It is essential to consider the potential impact of each type of error and determine the acceptable level of risk. All of these factors have the potential to introduce errors into our study. Ultimately, distorting our conclusions. Therefore, it is vital to approach hypothesis testing with caution and awareness of these potential pitfalls. By acknowledging the possibilities of mistakes, we can strive for more accurate and reliable scientific studies. Hypotheses and different research designs. We use different types of hypotheses in different research designs because hypotheses play a crucial role in guiding this study. So each type of research design has its own unique characteristics and requirements for creating and testing hypotheses. So when it comes to experimental research, hypotheses are formulated to test causal relationships between variables. In this type of research, the researcher manipulates independent variables and observes their effects on the dependent variables. The hypotheses in experimental research design often make predictions about specific outcomes or differences between different conditions of the experiment. For example, a hypothesis in experimental research might predict that participants who receive a particular treatment will perform better compared to those who do not receive the treatment. These hypotheses are often directional, meaning they specify the expected direction of the effect based on theoretical or empirical reasons. This allows researchers to have a clear expectations of what they anticipate to find during the experiment. Next category of research design is observational research design, and it is a valuable type of scientific investigation because it allows scientists to study the connections between different things without directly manipulating them. In observational studies, scientists simply observe and measure natural occurrences. This type of research often involves forming hypotheses that predict specific relationships or suggest potential connections. For example, a hypothesis might propose that smoking behavior is associated with an increased risk of lung cancer. However, conducting observational research can be complex due to the multitude of factors involved. Scientists must carefully consider all possibilities and control for any external influences that could impact the results. Next category of research design is correlational research. It is a type of study that we all know examines the relationship between two or more variables without making predictions about the cause and effect. It focuses on predicting the strength and direction of the connection between the variables. For example, hypothesis might predict a strong positive link between someone's wealth and their academic performance. However, it's important to note that these predictions do not imply causation but rather highlight the presence and intensity of the relationship between the variables. So, in each research design, hypotheses are an essential component as they serve as a roadmap for the entire investigation. These hypotheses offer a clear and measurable predictions about the relationship between various factors being studied. Whether it is exploring cause and effect in experimental research design, seeking connections in observational studies, or analyzing correlations in correlational research, hypotheses provide a foundation for testing ideas and conducting scientific studies. So, by formulating hypotheses, researchers can systematically investigate their theories and gather evidence to support or refute their claims. Evaluating and refining hypotheses. The process of scientific studies involve evaluating and refining hypotheses to prove their accuracy. This is done by utilizing evidence, theories, and methods. There are several key steps involved in the process of evaluation and refinement of hypotheses. Firstly, researchers begin by evaluating their initial hypothesis in relation to existing knowledge, theories, and early data. They assess whether the hypotheses are clear, testable, specific, and relevant. This evaluation helps determine if the hypotheses are suitable for further investigation or not. Next, researchers collect and analyze data through various means such as observation, experimentation, or other research methods. The collected data is then analyzed to test the hypothesis. By comparing the observed data with the predictions made by the hypothesis, researchers can determine if the evidence supports or disproves the hypothesis. This process of evaluating and refining hypotheses is crucial in scientific studies because it allows researchers to continuously improve their understanding of a particular phenomena or problem. By incorporating new evidence and adjusting their hypothesis accordingly, researchers can refine their theories and make more accurate predictions. Furthermore, this process promotes objectivity and rigor in scientific research. By systematically evaluating hypotheses and analyzing data, researchers ensure that their findings are based on solid evidence rather than personal bias or assumptions. In addition, the iterative nature of this process encourages collaboration and peer review within the scientific community. Researchers often share their hypotheses, data, and findings with others in order to receive feedback and validation. This collective approach helps to strengthen the overall scientific knowledge and ensure that conclusions are reliable and robust. Overall, the process of evaluation and refinement of a hypothesis is a fundamental aspect of the research. It enables researchers to continually improve their understanding of the natural world and develop more accurate explanations for the phenomena. Through careful evaluation, data analysis, and collaboration, researchers can advance our knowledge and make appropriate hypotheses. Next step is assessing the alternative explanations. Researchers follow a systematic process to evaluate and refine their hypothesis. They begin by understanding alternative explanations or rival hypotheses that could explain the phenomena they are studying. This step is crucial in ensuring that their hypotheses are strong and believable. Researchers carefully assess competing theories and potential variables that could affect their results. Next step is after analyzing their data and evaluating alternative explanations, researchers then make changes to their initial hypothesis. They might revise their hypothesis to better align with the data they collected or incorporate new information from other research. Next step is modifying variables and conditions. Researchers can modify the variables and conditions specified in their hypothesis, and this modification can be based on the findings in their data or theoretical considerations. They refine how they define certain variables, adjust their experimental procedures, or take into account additional factors that could influence the relationship they hypothesized. So, by following this process, researchers ensure that their hypotheses are well supported and accurate. Next step is uh, considering future research directions. When conducting a study, researchers not only focus on their current findings but also consider the implications for the future research. They strive to generate new ideas, propose alternative hypotheses, and suggest changes to research methodologies based on the insight gained from the study. This forward thinking approach ensures that scientific progress continues to evolve and expand. In addition to advancing knowledge, researchers have a responsibility to share their findings with others. They employ various means such as writing articles, presenting at conferences, or utilizing other communication channels to disseminate their work. Transparency is crucial during this process as researchers must openly discuss how they arrived at their initial hypothesis and how these evolved over them. By doing so, they enhance the credibility of their research and enable other researchers to replicate their experiments and obtain similar results. So, it is important to recognize that hypotheses are not set in stone. As scientists gather more evidence, generate new ideas, or explore different research methods, hypotheses can change. This fluidity demonstrate the dynamic nature of scientific researches where theories and assumptions are constantly evolving and adapting. It highlights the ongoing quest for knowledge and their continuous refinement of our understanding. Now, I will discuss types of hypotheses. Hypotheses play a very important role in guiding our research studies. They come in various forms and serve different purposes. And they help us to ask meaningful questions and correctly interpret our study findings. One of the main types of hypothesis is the null hypothesis, which suggests that there is no significant difference or relationship between variables. Essentially, it posits that any observed effects are merely due to chance or random variation. Researchers typically aim to reject the null hypothesis and support an alternative hypothesis. To illustrate this concept, let's consider an example where we are investigating the impact of a new teaching method on student performance. In this case, the null hypothesis, that is HO, would state that there is no significant difference in test scores between students who received the new teaching method and those who did not. This means that any disparities in performance can be attributed to chance rather than the teaching method itself. Next category of hypothesis is alternative hypothesis. This is the next category, that is alternative hypothesis. It is a crucial concept in the research because alternative hypothesis proposes a scientific and specific relationship or effect. It asserts that the differences or relationships observed in the data are not mere chance occurrences but rather hold significant meaning. Let's take the same example involving a new teaching method. The alternative hypothesis in this case would suggest that students who utilize this innovative approach will outperform their peers who do not employ it. In other words, it posits that there is a substantial improvement in test scores for those who adopt the new method. This distinction between the and alternative hypothesis is fundamental in scientific research. While the null hypothesis serves as a starting point, assuming no effect or relationship, the alternative hypothesis challenges this assumption by proposing a specific outcome. By doing so, it allows researchers to explore and analyze the potential impact of various factors on observed data. The alternative hypothesis plays a vital role in research because it goes beyond the null hypothesis by proposing a specific relationship or effect between variables. This hypothesis suggests that the observed differences or relationships in the data are not mere coincidences but rather hold important meanings. Next category of hypothesis is directional hypothesis. A directional hypothesis predicts the specific direction of the relationship between the variables, such as stating that one group will have more of a certain characteristic than another group. For example, in an experiment, we might hypothesize that participants who have been sleep deprived for 24 hours will have more cold symptoms after being exposed to a virus compared to participants who have not been sleep deprived. On the other hand, a non directional hypothesis simply states that there will be a difference between groups or conditions without specifying which one will be greater or smaller. For example, we could hypothesize that there will be a difference in the number of cold symptoms experienced after virus exposure between sleep deprived participant and non sleep deprived participants. Next category is a simple hypothesis. It is a hypothesis that is a clear statement and suggests a relationship or effect between different things. It is easy to understand and straightforward. For example, a simple hypothesis could be that there is a difference in test scores between two groups. Let's consider a study on how caffeine affects reaction times. A simple hypothesis for this study would be that consuming caffeine will result in faster reaction times compared to not consuming caffeine. This hypothesis proposes a direct relationship between caffeine consumption and reaction times. In research, simple hypotheses are valuable because they provide a clear focus and direction for this study. They allow researchers to make predictions and test specific relationships between variables. By formulating a simple hypothesis, researchers can design experiments and collect data to support or refute their hypothesis. Simple hypotheses are often used in scientific studies to investigate cause and effect relationships. They help researchers determine if one variable has a direct influence on another. In the example of the caffeine study, the hypothesis suggests that caffeine directly affects reaction time. Next category of hypothesis is complex hypothesis. These are an important aspect of advanced research. They involve multiple variables or conditions and predict intricate relationships or effects. These types of hypotheses are used in more sophisticated research designs and analysis. For example, let's consider a study on the impact of exercise and diet on weight loss. A complex hypothesis in this case would predict that individuals who both exercise regularly and follow a healthy diet will experience greater weight loss compared to those who only exercise or only follow a healthy diet. Essentially, combining exercise and a good diet leads to better results in terms of weight loss. A null hypothesis, on the other hand, suggests that there is no relationship or effect between variables. It assumes that any observed differences or associations are due to chance. Researchers often use null hypothesis as a starting point for their investigations. If they can reject the null hypothesis, it provides evidence for the presence of a relationship or effect. Hypotheses are important in research as they guide the scientific researches and connect theory to data. They are testable predictions that can be supported or disproven by empirical evidence. Scientists design studies to evaluate hypotheses and collect data that can confirm or disprove the predictions made. Hypotheses are based on background knowledge, observation, and existing literature, but they also go beyond what is already known to propose explanations for how or why something occurs. By formulating hypotheses, researchers can advance scientific understanding and contribute new insights. Now we will understand the hypothesis in qualitative research. In qualitative research, hypotheses are not as prominent as they are in quantitative research because we have discussed hypothesis in quantitative research. But qualitative studies focus on describing and understanding phenomena using subjective measurements. So the emphasis on constructing hypotheses is not as strong. While it is still possible to create hypotheses in qualitative research, the lack of specificity in the problem, methods, and procedures makes it less practical and advisable. Additionally, the importance and practice of formulating hypotheses vary across discipline. Uh, in epidemiological research, hypotheses are commonly used to establish causality, while in social sciences, the formulation of hypotheses depends more on the researcher and the academic discipline. Qualitative research often involves open ended questions and flexible data collection methods. Researchers aim to gain a deep understanding of the subject matter by exploring various perspectives and contexts. This approach allows for rich and detailed data that can capture the complexity of human experiences. Common methods used in qualitative research include interviews, observations, and document analysis. These methods provide researchers with the opportunity to gather in depth information and explore the nuances of the research topic. The data collected in qualitative research is typically analyzed through thematic analysis, content analysis, which involves identifying patterns and themes within the data. So it is not advisable to form a hypothesis in qualitative research. So, in the world of research, we use a process called iterative refinement to enhance the accuracy and dependability of our hypothesis. This iterative refinement is crucial as it contributes to the overall body of knowledge in our fields. Hypotheses play a significant role in sparking discovery and innovation, serving as the foundation for scientific inquiry. By employing hypothesis driven investigation and nurturing curiosity and critical thinking, researchers are able to unravel the mysteries of the universe and address important societal questions. These hypotheses act as guiding lights, leading researchers on a quest for understanding and truth. As we embark on future research endeavors, it is essential to recognize and appreciate the power of hypothesis in advancing scientific progress and expanding our collective knowledge. This is all about the hypothesis and its important in research process. Thank you.